Okay, logarithm part 1. In this video, I will talk about definition and derivatives. Derivative of this logarithm. Okay, let's start. Definition. We call it an Neperian logarithm, and it is often used to mean the natural logarithm. Natural logarithm is Neperian logarithm, or LN. L stands for logarithm and N for natural. However, as first defined by John Napier, it is a function given by I don't know, I missed something here. In terms of modern logarithm, it's given by or it's denoted by ln. It is the antiderivative of the function, which is x equal 1 over x. I will talk about that when I talk about derivative, and it is defined on 0 to plus infinity, open at 0, so it's from 0 plus and above, and vanishes at 1. We will see all of this when we start. Example 1, find the domain of the definition of ln function, ln x. Domain of ln x, always the inside ln, which is x, should be greater than 0, 0 plus. This means its domain is from 0, open at 0 to plus infinity. Find the domain of definition of ln 2x minus 1. The same, 2x minus 1 should be greater than 0. That always we have to do. The u, ln u, the u inside, it's a positive value always. This implies that x is greater than half. So what is the domain of definition in this case? If it is greater than half, so it's from half of open at half, not equal to half, greater than, so it goes up to plus infinity. Example 3, find the domain of definition. Find the domain of definition of f of x equal ln 3x minus 6 plus ln x plus 4. Okay, first I start over this one here. What is 3x minus 6 greater than 0? 3x minus 6 always should be positive. This means that x greater than 6 divided by 3, which is 2. This is important. And then x plus 4, right? X plus 4 should be greater than 0. This implies that x should be greater than minus 4. Okay, those two makes the domain of definition starts from 2 up to plus infinity. What's the meaning of greater than 2? And it is greater than minus 4. When we say greater than 2, this means greater than minus 4 as well, right? Greater than 2, this means it's greater than minus 4. So it starts from 2 and goes up to plus infinity. Or if you want, you can do that simultaneous table. X goes from minus infinity to plus infinity, right? And we have two values. We got two values, which is minus 4 and plus 2. The first inequality gives us x greater than 2. So it's from 2 or 2 plus, right? And above, I put dotted. This means it does not equal to 2. And here also, the second one, greater than minus 4. So it's from minus 4 up to plus infinity, right? Up to plus infinity. So they meet over here. So they meet from 2 plus to plus infinity. So it's greater than 2. Now the derivative. Ln x, f of x equal ln x. Its derivative is 1 over x. Its derivative is 1 over x. And we will see if it is ln u, how we got 1 over x from. Ln x is the antiderivative of 1 over x. So 1 over x is the derivative of ln x, and ln x is the antiderivative of 1 over x. 1 over x is always positive because the domain is always from 0 to plus infinity. Then, since 1 over x is strictly positive, then f is strictly increasing function. Then f is bijection from 0 to plus infinity onto another interval. And it admits inverse because it's strictly increasing function. It admits inverse. And we are going to see next chapter when we start the exponential, that exponential function is the inverse of ln, which is an exponential, right? Let's not take time on those. Mapping and bijection and so on. It is a mapping, right? And since to have one-to-one mapping, if we have a equal to b, then f of a equal f of b. So ln a equal ln b in this case. And if we have a less than b, then ln a less than ln b, because it is strictly increasing, so we don't change the inequality. All right, the important thing, if we have function in x, u of x, like what we got over here, it's not ln x, it's ln 2x minus 1, right? It's ln 2x minus 1. What happens in this case? Ln u of x, then its derivative, it's the derivative of ln u times the derivative of u prime. What is the derivative of ln u? It's 1 over u times u prime. So the answer is u prime over u. When I said it's ln x, what is the derivative of ln x? The derivative of ln x, or ln prime x, right? Or ln prime x is equal to the derivative of x, which is 1 over x. The derivative of x over x. The same when we have ln u. So what is the derivative of ln u? It's the derivative of u over u. That's it. So that's very simple. Let's have an example. Find the derivative of f of x, which is equal to ln 2x minus 1. What is the derivative of ln 2x minus 1? It's simply the derivative of u, which is derivative of 2x minus 1, which is just 2, over u, which is over 2x minus 1, right? Since the derivative of ln x is 1 over x, then what's the mean derivative of ln x is 1 over x? This means d ln x, right? D ln x over dx is equal to 1 over x. If we cross product here, we got d of ln x, right, is equal to dx over x, dx over x, yes, dx over x. If we integrate both sides, we got integral of dx over x is equal d integral of d ln x is only, right, ln x. So ln x, which is ln x plus c, which is ln x equal the integral of dx over x. So ln x is the integral, is the antiderivative of 1 over x dx, right, of 1 over x, because it's equal to integral dx over x, right? In general, if x belongs to r star, then integral of dx over x equal ln absolute value of x, because it should be positive, right? It should be positive. And integral of du over u directly equal d, directly equal ln u, ln absolute value of u plus c, and we are going to see some examples in the next video. Let's do some this discussion, and I'll keep the recall to the next video. Discussion, log x base a, why we're using ln. Ln, we are using it instead of log. It is log, but it is log base 10. So we are not using log anymore. Log x base a is simply equal to log x over log a. And when we say log x, this means it's base 10, and this is base 10. So log x is log x base 10. Log x over log a is log x base a, right? It's log x base 10 over log a base 10. I'm going to say some this example, or this rule, because we are going to solve some problems involving log in it. So simply, what is log x base 10? When the log is base 10, it changed directly to ln. It's ln x over ln a, where a is